Okay, now looking at some quicker problems, just doing some antiderivatives in definite integrals. And you only know at this point two types of antiderivatives, and that is using the power rule or recognition. And these first three are all power rule. The first one's ready to go. We have x squared. You will add 1 to the previous exponent, so x cubed, and you divide by the new exponent, minus the 3 on this one doesn't really come into play. You're focusing on the exponent. That's x to the first. 1 plus 1 is 2, and divide by the 2. And then 1 is the derivative of x. Put a plus c, and that's all there is for number 8. Number 9, as it's written, it's a product, and the easiest way to do this one would be to distribute that x cubed. Change problem to x to the fourth plus x cubed dx, and then it's ready to be power ruled. 4 plus 1 is 5. Divide by 5 plus 3 plus 1, x to the fourth, and divide by the new exponent. Write a plus c, and then move on with your life. The last one, number 10, this will be power ruled, but before I'm ready to power rule it, it might be better and easier for you to see if you change all of these to x to some number power. So root x, I'm going to change x to the 1/2. 3x, well, that's already 3 times x to a power. And then this one, 1 over x squared, we're going to bring that x up to the top, make it x to the negative 2. And then we will add 1 to each of those exponents and divide by the new. So 1/2 plus 1 is 3/2. Divide by 3/2. Plus x to the 1 plus 1 is x squared. Divide by 2. And that 3 just comes along for the ride. Minus negative 2 plus 1 is negative 1, and we will divide by negative 1. Plus c. I'm okay if you stop here. If you want to circle that and just move on, you can. If you want to clean that up, dividing by 3/2 is the same as multiplying by 2/3. So 2/3 x to the 3/2. This one you can't really do much with it. So 3x squared divided by 2. This one, minus a negative, I'm going to make that plus, and I'm going to move that x to the bottom, make it 1 over x, and I am okay with both of those answers for number 10. Right now I just want to see that you can do the antiderivative. We'll worry about your simplification skills later in life. Looking at the next three, 1 over x plus sine x, that one, there's really no work to that. That's recognition. Do not bring the x up to the top because you should recognize 1 over x as the derivative of the natural log of x. And then sine x, the antiderivative of that is negative cosine x plus c, and you're done with number 11. Number 12, we actually need to use an identity because you should know that tangent squared x plus 1 does equal secant squared x. And if I move that 1 over, I can replace tangent squared with secant squared of x minus 1. And the advantage to that is it then becomes recognition. Secant squared, you should just know that that's the derivative of tangent. And 1 is the derivative of x plus c, and there's your answer for 12. 13 is also a recognition one. There's no work to 13. The antiderivative of 1 over 1 plus x squared, you should just know that that is the derivative of arctan x. And so you just write it down and move on. And the last three antiderivatives, this first one's going to be the toughest one. Sine 2x, we have to use another identity for that, and sine 2x can be replaced. That is your double angle for sine. That can be replaced with 2 sine x cosine x. My denominator is cosine x. And we're doing the antiderivative of that, which is going to get really nice because the cosines cancel out, and we're left with just the antiderivative of 2 sine x dx, and that would be negative 2 cosine x plus c. That 2 just comes down for the ride. You don't really do anything with it. You do the antiderivative of sine, which is negative cosine, and I just kept the 2. Number 15 is kind of the same as the very final step of 14. Secant tangent, that you should just recognize that is the derivative of secant x. So the antiderivative of secant x tangent x is secant x, and that 7 in front just comes along for the ride. So that's all there is to number 15. And 16 is really something that belongs in the future when we learn how to integrate with u sub, But if you look at the bottom, we have x squared minus 7. The derivative of x squared minus 7 is 2x. And at one point in your life, we learned that the derivative of the natural log of anything is the derivative of the inside over the inside. So if I see a fraction in an antiderivative and I notice that the top is the derivative of the bottom, that means this antiderivative is the natural log of the bottom plus c, and there is your answer. And that's kind of recognition. Technically it's u substitution, which y'all don't know yet.